I'd like to show you the TIBCO data science platform and how it can be used by everyone and how it covers the entire data science lifecycle. I'll show how TIBCO's data science team came together in a few days to produce this analysis of life expectancy. We shared our findings in this collaborative workspace. Our analyst Neil created these dashboards for data exploration and wrangling, including imputation of missing values and variable recommendations from our AI engine. As a business user, I was able to understand these visual workflows and add my own basic models using AutoML and use decision trees for easy interpretation. Prem, our data scientist, created this set of predictive models. And we were easily able to add more advanced models that our developer Emily had coded in a Python notebook. Prem then deployed the best models for batch scoring on a schedule and for real-time scoring that was approved for production use. And finally, our models were deployed back into our dashboards to be analyzed by Neil for policy recommendations.
To start, we went to the HTX website where there was World Bank database data and World Health Organization data for indicators on countries around the globe. We downloaded those CSVs, which we could simply drag and drop into Spotfire. Now, Spotfire automatically recognized the structure of those CSVs and recommended that we combine all the health indicator data together and the World Bank indicator data together. This was automatically recorded in the Spotfire data canvas, which is fully editable to the user. Now we need to combine the two different data tables, so we'll add rows, and even though the data has different column names, we can choose to match them up and stack them into the same data table. Next, we need to go ahead and filter down to our years of interest, the years 2000 to 2016. Any data transformation that I do is automatically logged in Spotfire and is fully editable. Now the data table preview shows me that this is all in a tall and narrow format with indicators and values in one column. So I'll need to pivot this into a wide format, and I'll use Spotfire's pivoting transformation for that. Now that my data has all been brought together, I'll start exploring it, and I'll use Spotfire's natural language query to find relationships with life expectancy. I see a strong relationship with antiretroviral therapy and another strong relationship with children ages 0 to 14 with HIV. I can also go to my data panel and look at all the thousands of variables in my data set. I can look for a target variable like life expectancy, and my AI recommendations are giving me the strongest relationships ranked in order of those strength. I'll select these charts and I can go ahead and further explore those. Now what if I want to view all of this together in a holistic view? I'll use Spotfire's data relationships tool to do a linear regression on life expectancy and compare that to all the other variables. Spotfire automatically creates these visualizations where I can compare the strength of the relationship with the variables, and I can see positive and negative correlations for each. I get a p-value for statistical significance as well as r-squared for correlation. I created another exploratory bar chart that sorts each variable by its p-value, and now I want to select variables. I want to select variables that are related to my life expectancy, but are not like life expectancy with males and females, which are included in my target variable. I also want to exclude variables like mortality rate, which have low predictive value. So here I've selected strongly related variables I felt governments could use to affect policy change, as well as Gartner's recommended variables. Now I want to handle missing values. So this heat map shows all the holes in my data in white, and I can see all of the variables at the bottom as well as the countries and the years on the y-axis. To impute these missing values, I use a linear interpolation and spline interpolation calculation for each variable. Evaluating graphically on the right for each country, I can see the spline in red, the linear in yellow, and the raw data in blue. It appears that the linear interpolation is the best choice for imputing. Now with my raw data at the top, you can see all the missing values, but below that I can see the interpolated data, and this has a lot of those missing values filled in. There are still some missing values for countries that didn't have any observations to interpolate on, but overall this is a more complete data set. Now with this data, I can do a very basic comparative analysis where I can select individual variables like life expectancy, and I can see how countries compare to Australia and New Zealand, both temporally and geographically. I can select time ranges for countries to look at subsets, but I want to do a more predictive analysis, so I'm going to hand this off to other data scientists.
Now that Neil has wrangled the data, the rest of the team can take over. So I can search for the data sets he shared with me, and here they are. But down here is the project that we've already started, so I can see what the team has been working on. And I can see how Neil the analyst, and Prem, our citizen data scientist, and Emily the developer have been collaborating. The first thing we do is to build some basic exploratory models. This workflow takes Neil's dataset and categorizes countries into those with high or low life expectancy. To get things going, a business user like myself can use AutoML and this will automatically generate entire workflows that build features or a range of models like in this workflow here. And then it will recommend the best strategy and the best model. I can also build, say, a simple decision tree, so I can get an idea of how these variables interact with each other. Using that as a starting point, Prem and I can build other classification models and evaluate them using standard methods like ROC charts and confusion matrices and so on. But now I can pass control over to Prem to build more sophisticated regression models, and you can see he's been helped here by the rest of the team developing a full modeling workflow to build regressions that predict longevity. We start with some basic data prep, filtering to a reduced list of countries and filtering out columns that have very few values in the data set. Then we replace any null values. To select which variables to use, we use correlation filtering. It automatically filters out any variables that are too closely correlated. Here you see one metric for unemployment is too similar to another, so we throw it out. Then we normalize. As always, no coding required, easy to configure. And then we split into training and testing, and we build our models. It's very easy to set these up. For example, this random forest is just dragged onto the workflow. You choose your variables, and then you can use default or optimized parameters. We can then evaluate the models using standard statistics like R-squared and MAPE, and we can look at charts of predicted versus actuals. There's a couple of models here that seem to predict pretty well. Still, we decided we wanted to add a nice sklearn version of an AdaBoost model. So we asked Emily to create this as a Python notebook. She works in her own environment, and then the engine can inspect her code, understand the inputs and outputs, and then fit it back into the visual workflow. Then we can join her results to the other predictions and choose the model we prefer. We're going to use gradient-boosted trees for batch scoring, but linear regression is faster for real-time scoring. So we export those out for use later. We've also got our measures of variable importance, and we're ready for deployment. Having built his models, Prem exports them to the workspace where they can be used for deployment. Now, the simplest way to deploy is for batch scoring in another workflow. This workflow tests the accuracy of the loaded model against the latest data, and if the error is too high, then the workflow fails. This can then be deployed as a scheduled job where we run some code, train our models, and test them for accuracy, sending an email alert on failure. Or Prem can simply click a button to create a REST engine for real-time scoring and test that it gives the right response, 83 years of age for Australia. But most importantly, we can deploy live models back to our dashboard for analysis by Neil.
After the rest of the team has completed their predictive analysis workflow in TIBCO Data Science, I can connect directly to the workflow from Spotfire and get different predictions by country. So if I select Australia and rerun the workflow, I'll get results for Australia. After the workflow re-executes, I can explore life expectancy over time and how the different regression models performed. I can see that the AdaBoost method from my Python notebook performed pretty well compared to the actual life expectancy values. I can also explore the other regression methods from the TIBCO Data Science workflow and see how they compared to the actual as well. In the center here, I have variable importance by Australia and across all of my countries in my dataset for worldwide. I can see that consumer price index ranks high, as well as percent of the female population ages 20 to 24 with no education. Selecting some of the most important variables and comparing them to the worldwide, I see that some of these rank a little bit lower with the worldwide variable importance, but many of them are towards the top. I can see this delta change over here on the right, where I can select this variable that is very important for the worldwide variable importance, but not as important for Australia, and that's time-related underemployment for females. That is less important with Australia. However, these other variables have increased importance with Australia, and these are things like the average years of schooling for 15-year-old females and the percentage of the female population with no education. I can continue exploring this and even sort by country to see the other top predictors for Australia, things like CO2 emissions as a percentage of GDP and the amount of schooling for 15-year-old females. I can also explore the deltas to find predictors that are common with the global predictors, though some of these aren't strong for either. Overall, this is a great way for any country to improve their policies and increase life expectancy.